Okay, everyone, this is going to be the last lesson of Unit 0, and Unit 0 is review of Math 1 and Math 2, even though it was a lot. It kind of all was review. Parent functions. Say parent functions. Parent functions. So there's going to be like 12 to 16 that you're going to have memorized by the end of the year. But right now we're going to start with these 4. Are you ready? Here we go. The first one is linear. We're going to make a quick table. You always get to pick the x values, you guys, but you want to pick x values that you know and love and that make life easy for you. So you've been told how many points you actually need to graph a line. Okay, you don't need 5, but that's what your teachers always did. I don't know why, but you actually only need how many points? Oh, come on, come on. How many to make a line? How many points do you need? Yeah, you really only need 2. Okay. How many do we want to graph? 5? Would that make you happy? You can't go against what your middle school teacher did. Okay, so this linear, you see how this just says y equals x? But it says f of x, but f of x is y. So if we plug in these values for x, we would just get the exact same y values, right? So we're going to graph. Yes, I'm going fast because I believe in you. You are capable. Why no graph on this first one? I don't know, actually. I don't know. Okay. I'm going to try to not say on this video. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Do you remember this line? So this is called the parent graph. It's also called an identity graph. But the line y equals x, it has a y-intercept of 0 and a slope of 1. And here are the properties. The domain, what x values will this hit? Is it going to negative infinity to positive infinity? Yes. So the domain is all real x values. And the range, all real y. So the domain and range is kind of boring. That's going to get more exciting as we look into new functions. Yay. Okay, what's this one called? This is important for you. When you see this and I say, what type of function is this? You're going to name it. What are you going to name it? Linear. So I heard last week I would say, what is this? And someone said, it's an mx plus b. No. Okay, it's called a linear function. Everyone say linear function. Fantastic. Here we go. The next one is a quadratic. Say quadratic function. Here we go. And the same x values work well for this one. And what we're going to do to every x value is we're going to square it. So what's -2 quantity squared? 4. -1 quantity squared. 0 squared, 1 squared, 2 squared. This one, does this graph, oh, it goes to 8, but we know that 3 squared is also 9, so you can go off the graph a little bit if you want to make it more official. And that's our parent function parabola, or quadratic. Okay, that's how they all start. This is the parent. And then as we multiply, divide, add, and subtract to this x squared, we've seen the parabola move around the paper or get stretched tall or stretched wide. But this is called the parent function. Now the domain is still all real x because it goes to negative infinity to positive infinity. But the range, does it hit every y value? No. So the range is going to be different for each one. And how do we describe it for all of them? Let's think about this. So this range, if we have a vertex, what do we like to call our vertex? We like to call our vertex, our vertex, we call it HK. So this is concave up. If it's concave up, the range will be all the y values greater than or equal to the y value of the vertex, which is k. And if it's concave down, the range will be all the y values less than or equal to the y value of the vertex. So that's going to change every time, and we're going to practice that. All right, absolute value. The same y value, sorry, the same x values work well again, but we're not squaring them. What do we do for absolute value? What is an absolute value? Like, what operation does it do? Yeah, it makes everything positive. Makes input positive. That's what absolute value does. Okay, absolute value of -2 is it 4, like this? No, it's 2. Okay, absolute value of -1, 1, 0, 1, 2. So, is it going to look exactly the same as a quadratic? Nope, it's not. Otherwise, it would be a quadratic, but it's different. This has 2 straight lines going out with the slopes of 1 from the vertex. Do you see the difference here? So this one is curving up, and this one is 1 over 1, 1 over 1, 1 over 1. Same as above. Okay? The domain and range of the absolute value function is the same as a quadratic. Okay, the last one we're going to memorize is the square root function. We graphed these a little bit. Now, I want you to wake up. Are you awake? Okay. Do these x values, will the same ones work well? I kept saying that. These x values work well for here. These work well for here. Does -2 work well in a square root? Why not? It's not defined, right? So, is a square root defined for any negative numbers? Can we take the square root of negative numbers and get a real solution? Nope. So what's the first number we should start with? What's the smallest number that's positive? Smaller than 2. Smaller than 1. 0. What's the square root of 0? 0. Okay. What's the next number you know the square root of? What's the square root of 1? Okay. Do you know the square root of 2 in your head? I think that's from my head, but it's been a while. Anyone want to check that? I think that's what it is. Find the square root of 3. Didn't we use the square root of 3 last week? 1 point on 3? Are you guessing? If only I was near a calculator in this math classroom on this computer. Oof. Here we go. 2 square root. Oh, I missed a number here. I was close. And 3 square root. Who said 1.7? Way to go, buddy. I don't even have that one memorized. That was good. Okay, let's graph this. 0, 0, 1, 1, 2, 1.4, 3, 1.7, 4, 2. And it looks like an arm. Well, that's what I think it looks like. Okay. So the domain will be to the right or left of starting X value, but they're going to flip and flop and turn around, so we don't really know. And then the range will be up or down. I should have said greater than or less than, but we're saying up or down of starting point eek of starting Y value. Okay, what do you need to know about these? I've told students in the past, memorize, ta-da, memorize this page. What do you need to know? You need to know, like, if you see the picture, you should be able to name, that's an absolute value. If you see a line, you should say, oh, that's y equals x. If you see the word quadratic, you shouldn't see this picture in your head. If you see the square root of x, you should know that's a square root, and it draws this picture. So these three things, domain and range, we're going to work on. We're going to work on that a lot next unit. But can you name all, like there's 3, 3, 3, 3. Can you match them together? Yep. Okay. Holy moly, this is a lot of writing. Here's what we're going to do. I'm going to end this video, and you're going to copy this off of a PDF, a picture. Okay? That's what we're going to do. Thanks for watching.